Hi, Assalamualaikum everyone, and to our respected lecturer. Today, our team will present the final report for our project management assignment, which is the implementation of an energy monitoring system at the Compressor and Chiller House. I am Muiz, the project lead, and I am joined by my team member, which is Faizal, Aisyah, and Aini, which is them will be introduced by themselves. To begin, let's look at the background of our project. We are focusing on a high utility area, the compressor and chiller house. In any industrial setup, energy consumption in this area is a massive, yet often poorly tracked. Our project aims to transition from manual monitoring to an automatic, industrial-grade solution using high precision meter like the Schneider BTE2542 and Socomax Dairis A14. This ensures we have a long-term reliability and accurate data for utility management. Next, we go to the problem statement. Why is the project necessary? We identify three primary problems. First, there is a total lack of real-time visibility into how energy is being consumed in the chiller house. Second, without high precision sub-metering, it is impossible for management to identifying energy peak or wastage. And third, the current lack of data point prevent the facility from conducting a successful energy audit to improve efficiency. Next, we go to the project objective. Based on these challenges, we set three clear objectives for our project. First, to design and fully install an energy monitoring system within a total budget of $8,800. Second, to stabilize 100% data transparency across 9 monitoring points using split core current transformer. And finally, to complete the entire project lifecycle within our scheduled 20-day duration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Faisal bin Izan, and my matrix number is TB25002. Now, what I want to tell is about, I will present about the Gantt chart project and explain the critical phases of the energy monitoring system project for compressor and chiller house. As you can see at the project, the Gantt chart project is overall project flow for 20 days, and we can define based on the Gantt chart. The project is divided into 5 phases. The first phases is the planning phase, which is including conduct site and energy update, define project scope, and develop project schedule. So, for define project scope, we have 1 day, and the yellow one, you can see that it was for the planet day is 1 day, and follow the actual day for 1 day. Conduct site and energy update, it is for 3 days, but we go over it and it takes 4 days. Develop project schedule for 2 days, it takes for the actual day for 3 days. 2.0 is system design phase, design monitoring system architecture, it for 3 days, from day 4 to day 6, but we take from day 5 to day 7. Next is select energy meters and sensors, so it from day 6 to day 7, we take from day 7 to day 8. This is because we don't want to overload our workers when they do their job, so it can be done more smoothly and safely. Next is design data communication system. It is for 2 days, from day 7 to day 8. but we start from day 8 to day 9. 3.0 is the installation and integration phase. So install compressor monitoring system. It takes 3 days, and we also take 3 days, but the plan day start from the 9. It is when the design data communication system end, but we take from the next day at the 10 THD. So it take from day 10 to day 12. Next is for install chiller monitoring system. It from day 11 until day 13, but we take from day 12 to day 14. Integrate and configure monitoring system. It will be planned for day 13 until day 15, but we actual day for days 14 and we end at day 16. 4.0 is the testing and commissioning phase. The test system functionality, it will be for 2 days and we follow it for 2 days. It in the 16 and 17 days. Day 16 and day 17. So validate the energy data accuracy. Also follow the planet day for the day 17 and day 18. 5.0 is monitoring and reporting phase. So monitor energy data, we take 2 days. Also follow the plan day. It start at day 18 and end at the day 19. Analyze system performance. It takes only 1 day and we take it at 19 day. Same day for monitor, the end day for monitor energy data. And lastly, prepare final report. We can see that we start the prepare final report from the day that we monitor energy data. So we will compile it in the final report and give it. So from day 18 to day 20. Okay, now we will be explaining about the critical phase for system design. The first critical phase is system design, which takes for 5 days and take 25% from overall project flow. The design error are difficult to fix in the next phase. It will be determine the quality and effectiveness of the overall project system and being on the critical path if delays, and it will be affect the project. So during this phase, the team will be design the overall monitoring system for the architecture. So select suitable energy meters and sensor for the compressor and chiller system. Design the data communication network using RS485 and internet. This is what the team will be doing at this phase. This is why I take this for the critical phase. So this phase is critical because any design error will affect the installation process and the reliability of energy data, and it will be difficult to correct after installation. Now we move on to the critical phase, phase 2, and it is for the installation and integration, and it takes for 7 days. In this phase, the following activities are carried out. Number 1, the installation of monitoring equipment in the compressor house. 2, the installation of monitoring equipment in the chiller house. Number 3 is the integration and configuration of all devices to ensure proper communication and accurate data collection. This phase lies on the critical path with no buffer time. Any delay in installation will directly delay the overall project completion. So, why this phase is critical? So, number 1, it main implementation phase is hands-on implementation. So, it will be directly to the second point, no slack time. So, if it was delayed, directly affect the project. So, it will be taking more than 20 days to complete. So, work at 2 locations. For number 1, it will be at the compressor house, and number 2, chiller house. So, it requires tight coordination between team members to complete the task for the first location, and will be helping each other for the next phase or location for the work. So, and for lastly, it will be electrical work. It will be causing a lot of requires for high safety. So for the conclusion, the system design and installation and integration phases are the most critical, with a total duration of 12 days, and effective planning, close supervision, and timely execution during these phases are essential to ensure the project is completed on schedule and performed as expected. Thank you.
Assalamualaikum, my name is Aimee Adana Krabitin Samri, DG24030. So here I am to present the estimate cost per task or subtask of our project. So our task contain 5 phases, which is planning phase, system design phase, installation and integration phase, testing and commissioning phase, monitoring and reporting phase. Firstly, for planning phase, which requires 7 days duration, and the estimate cost is 1,800 ringgit Malaysia. So for the scope description, this phase requirements, analysis and project scheduling. So next is system design phase, which the duration for the phase is 11 days, and the estimate cost is 6,500 ringgit Malaysia. This scope description is sensor layout design, data acquisition, planning, dashboard, and software architecture. So next is installation and integration phase, which also require duration for 11 days, and estimate cost, which is 6,500 ringgit Malaysia. So for this phase, this is for sensor installation, wiring works, and software integration. Next is testing and commissioning phase, which required 4 days duration, and the estimate cost for the phase is 2,500 ringgit Malaysia. So this phase is for system calibration, performance verification. So lastly, for monitoring and reporting phase, which require 3 days duration, and the estimate cost is 1,500 ringgit Malaysia. So this phase is especially for operator training and documentation. For the equipment and material cost breakdown, which this is for the equipment that we needed for our project. So we have 8 items, which is the first power meter. Specifications in the PM 5560. We only need 1, and unit cost is 3,800 Malaysia. So next is energy submitter. The specification is Socomac Beres A40. We need this item 3 quantity, and unit of cost is 900, which is the total for 3 quantity is 2,700. So the third one is split core current transformer. So the specification is 400A to 600A class 1.0. For this item, we need 9 quantity, and unit per cost is 150 ringgit Malaysia. And for the total for 9 of this item is 1,350 ringgit Malaysia. So next item is voltage protection and fuse. The specification is 3-phase fuse input. We only need 1 set, which unit per cost is 250, and since we need only 1, so the total for this item is only 250 ringgit Malaysia. Next is RS485 communication cable. Specification for the item is shaded twisted pair. So for this quantity, we only need 80 meter, and unit per cost is 4, and total for this item is 320 ringgit Malaysia. Next is Ethernet cable. Specification for this item is Cat-C industrial grade. The quantity for this item is 40 meter, and unit cost is 3 ringgit Malaysia, and total for this item is 120 ringgit Malaysia. Next is panel accessories. Specification for this item is DIN rail, terminals, and levels. We only need 1 set, which unit per cost is 300 ringgit Malaysia. So the total for the item is only 300 ringgit Malaysia. Lastly, we need item is panel modification and mounting. Specification for this item is panel cutout and mounting. We only need 1 quantity for this item, which unit per cost is 400 ringgit Malaysia, and total for this item is 400 ringgit Malaysia. So total estimate project cost for this equipment and material cost breakdown is 9,240 ringgit Malaysia. This is for the cost summary table. So this is actually just a summary table from the previous slide. which is the cost category for planning phase. The estimate cost is 1,800, system design phase 6,500, installation and integration phase 6,500, testing and commissioning phase 2,500, monitoring and reporting phase 1,500. So the total project cost is 18,800 ringgit Malaysia.
Assalamualaikum dan selamat sejahtera. Saya Aisyah dan saya akan explain tentang struktur WBS dan bagaimana task diagihkan dalam projek kita. So WBS atau Work Breakdown Structure ialah cara untuk breakdown projek pada phase and sub task supaya lebih mudah diurus. So projek kita ada 5 main phase. Planning phase iaitu termasuk define project scope and conduct energy audit. Next is system design phase, involve design monitoring system and select energy meters and sensors. Next is installation and integration phase, di mana kita install and integrate system. And next is testing and commissioning phase, untuk test system functionality and validate data accuracy. Dan the last one is monitoring and reporting phase, untuk monitor energy data and prepare final report. So untuk task allocation, setiap ahli ada tanggungjawab masing-masing. For me, I handle develop project schedule, which is task 1.3, and prepare final report, task 5.3. So saya akan terangkan WBS project kita. Dengan WBS ni, semua task jelas dan kerja pun tak overlap dan projek akan dapat disiapkan on time. So slide ni dia tunjuk tentang team task allocation for setiap team members berdasarkan WBS project. So setiap ahli diberikan peranan yang jelas supaya kerja lebih tersusun dan tidak bertindih. So Muiz dia fokus pada project scope, monitoring data dan juga final report. Aimi pula dia assist sensor selection and validate data energy accuracy. Faisal dia bertanggungjawab terhadap energy audit, system design, installation, integration and testing. Manakala saya sendiri handle project scheduling, WBS coordination dan juga final report preparation yang melibatkan penyelarasan keseluruhan projek.
In conclusion, our energy monitoring system is now fully operational. By integrating industrial-grade meter, we have achieved 100% data visibility for the chiller house, allowing for the better energy management. The project was a success, staying within the RM 18,800 budget and meeting all the deadline. We would like to thank our team for their hard work and our lecturer for the guidance. That's all from me and my team. Thanks for your watching.